Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, I catch up with Howard Wu, co-founder of the Aleo Network, and Alex Pruden, executive director of the Aleo Foundation. We do a long overdue revisit of the Aleo project on the show. The last time we covered all this was at the beginning of the project, very early on, back in 2020. And in this interview, I get a chance to learn about all of the lessons learned, technical decisions, shifts, and breakthroughs that they've experienced as they build out their system. We also revisit the initial goals of the project, that is to deliver a safe and private experience to end users of this decentralized system. It was really fun to catch up with both of them. And I do want to quickly mention my connection to the project. The company is a sometimes sponsor of our events like ZK Summit, as well as a sponsor of this show. Although, just to note, they are not a sponsor of this episode, as this is not a sponsored interview. I don't do those. But if you are a listener to the show, you've probably heard them mentioned at the beginning of other episodes. I'm also an investor through the ZK Validator. I was personally an early contributor. So yeah, I feel like I've been around this project for a long time. I've also gotten a chance to see it through its many iterations. It was very fun to explore with them the status of the project as it gets closer to launch. Now, before we kick off, I just want to let you know about ZK Hack 4. The event just kicked off yesterday on January 16th, and it runs until February 6th. This is not a hackathon, but more like a crash course in ZK. It's pretty unique as an event in that it combines three things over the span of 4 weeks. That is, it's a live virtual workshop series with workshops running every Tuesday. It's a CTF-like puzzle hacking competition, and it's a job fair. I've added a link to our next sessions in the show notes. I want to say a big thank you to the ZK Hack 4 workshop partners, RISC-0 and Polygon Labs, as well as Geometry Research, who have built the puzzles for this edition. As you may know, the ZK Hack is actually a separate project from the podcast, but I'm involved in both of them, and I wanted to let you know about it. Our next workshop is on January 23rd, followed by one on the 30th and on February 6th. Hope to see you there. Hope if you're already hacking on the puzzles that you're having fun, and we can see you over on the Discord. I've added all links in the show notes. Now, Tanya will share a little bit about this week's sponsor.
Launching soon, Namada is a proof-of-stake L1 blockchain focused on multi-chain asset-agnostic privacy via a unified set. Namada is natively interoperable, with fast finality chains via IBC and with Ethereum using a trust-minimized bridge. Any compatible assets from these ecosystems, whether fungible or non-fungible, can join Namada's unified shielded set, effectively erasing the fragmentation of privacy sets that has limited multi-chain privacy guarantees in the past. By remaining within the shielded set, users can utilize shielded actions to engage privately with applications on various chains, including Ethereum, Osmosis, and Celestia, that are not natively private. Namada's unique incentivization is embodied in its shielded set rewards. These rewards function as a bootstrapping tool, rewarding multi-chain users who enhance the overall privacy of Namada participants. Follow Namada on Twitter @Namada for more information and join the community on Discord, discord.gg/Namada. And now, here's our episode.
Today, I'm here with Howard Wu, co-founder of the Aleo project, and Alex Pruden, executive director of the newly founded Aleo Network Foundation. Welcome to the show, both of you.
Thanks. It's great to be here.
Thanks for having me again, Anna.
Yeah, I should say welcome back. Both of you have been on the show before. It's been a long time since we've had an episode on Aleo, and I think it's a really good moment for us to do a catch-up. So let's kick it off. Howard, I sort of want to start with you because the last time you were on the show was August 2020. And this was right at the beginning of Aleo. But actually, I want to throw back to an even earlier episode. You were on episode 38. You were the first person to come on the show and define snarks to our audience, which is kind of cool. So that was all the way back in 2018.
I think it was like July or August, something like that.
Yeah, it was a long, long time ago. Actually, that was like within the first year of the show.
Yeah.
It's really interesting listening to you describe snarks today as well. Like, I will add that link to the show notes. Something that I noticed, though, back then, I don't know if the breakdown of the IOP and the polynomial commitment scheme had been, like, properly communicated yet or even thought of. Yeah.
Yeah, I think a lot of the formative work back then was still early in terms of, like, reaching practical maturity. There was also that era where people started realizing, hey, there's like different ways we can construct Merkle trees, like polynomially based, and there's now Verkle trees as a concept. There's been a lot of new primitives that have been invented since that time, which have accelerated the proving aspect of snarks. I feel like, on the verifying side, pairings remain like the fastest, and people continue to kind of use those like where it's necessary. And this even is also even a call out to Georgios, where he had this presentation several years ago at ZK Summit saying Groth is not dead, and Groth is still not dead to this day.
Still
Like
not
I
dead.
still see it out in the wild. I still see research papers reference it. I still see projects that are trying to generate, their initial POCs use it. Like it is very much still a viable proof system. And I think that is a testament to just like, there's a lot of work that has gone into this space, but there's also a clear demonstration of history and lineage that has remained even since the original episode that we did.
Totally. It's a time capsule, but it's actually a really fascinating one. To give some context, at the time, Starks were brand new and kind of unusable, I think. And this is before Plonk, too. Like, this is long before Plonk or Halo or any of the systems that kind of came after that we are very familiar with now.
I think even at the time, roll-ups were still a new concept, if at all.
I don't think they existed, actually.
Yeah, I remember when Barry put out that blog post about it, but I don't even think roll-ups were around back then. So yeah, I mean, Starks are a great example of a technology that emerged since that have been very applicable for roll-ups. It's a great use for that because you're talking about these massive bulk transactions that you're willing to pay the verifier time for, and the storage size of it's reasonable for so many transactions to amortize across. It's a clear demonstration of where people have gone with that technology. And now recently you see it with folding and ZKML. These are entirely new primitives, entirely new concepts that are only a year or two old. So it's really fresh.
Totally. A few years after that, you came on to basically introduce Aleo. I want to later on in this episode talk about the evolution of the Aleo stack, but let's start more with the evolution of the Aleo company or project and sort of your position in it, what you learned over the last few years.
Where do I begin?
What did you learn?
I will say that even though the journey in my mind is still beginning, I've learned a lot, and I feel like it's forced me to teach myself a lot of things along the way, and most of it being non-technical things. Certainly I've never built a business before this, and doing that with Alex has been both a pleasure and quite a journey. It's tested a lot of our skills. Yeah, I guess overall, I have found that it's incredibly important who you bring on to a team.
Oh, yeah.
And it's incredibly important how you interact with those team members. Everything that you build as a project really emerges out of the skills that the people around you bring to the table. And without those skill sets, you don't have a team. I think that was probably the biggest kind of journey or kind of lesson that I have taken away from this, just on a human level. And then I'd say, like, double clicking into it, I've also realized just the importance of setting the right mission and vision to guide a group. And I think that this also touches into the point about why we think a foundation is so important. It's that in order for, at least from my view, in order for this technology to really, really take rise, and I mean ZK to take rise, like, I think you need to have both an ecosystem and a product-driven focus for this technology.
Yeah.
And this is where I think Alex and I are in a really unique position to take this to the next step and make this happen. But it was something that was really emergent over the past 2 years that really helped me to start to see this and come around to it. And, this does touch a bit into the stack. I would say that, like, on a high level, a lot of the existing code that we had with it when we started Aleo was based off of libsnark and based off of Zexy.
Yeah.
Very early software designs at the time. And we learned the hard way, admittedly, that a lot of those design choices weren't the right ones, not only because it was difficult as a developer to use that stack, but also from a feature set, it was either incomplete or it kind of optimized in the wrong directions. And we had to go back and rebuild a lot of that. And so this was something that with the engineering team, I would say was a really big shift in our focus, was moving from that research domain into that product domain.
Yeah.
And then I'd say on the other side, which was on the community front, that I felt like we really had to figure out a good cadence and a good way to get feedback from the community. I mean, now we're starting to really formalize this concept around ARCs, which are our kind of Aleo request for comments. I think that that's going to become an emergent aspect of the foundation, and I'll let Alex kind of chat on that side of things. But I think that just having a feedback loop that is iterative rather than kind of master planning was something that was much more hard learned over time. We had these grand plans about how we wanted to evolve the language and how we wanted to evolve the feature sets. And we realized actually it's better to look at what applications grantees are building and figure out what are the missing opcodes and pieces there and just plug it in iteratively. And that was something that, at least for me, has been an important part of this process, is just, I'd say one is finding the right team members, and then two, figuring out a good feedback loop with them.
Interesting.
Yeah.
Those ARCs that you just mentioned, are those the equivalent of like the EIP?
Yeah,
Okay.
it's effectively mirroring the kind of BIPS process or the EIP, ERC process. It's something that I think we still need to formalize more so. Like, as you know, governance is an unsolved problem. But I think that especially when it comes to ZK tech, you have even more on the line now. But, it's something that I think is also an opportunity, because the fact that you have these lightweight verifiers, so you could also design things that are much more formalized than before. And it's an open question whether on-chain or off-chain governance is going to be the right thing. I think it's going to be a bit of a hybrid. You probably want some form of voting with stake on-chain, but you probably want some human process to make sure people are adhering to the protocol of ARCs in this case. But yeah, I think that's probably something best touched by Alex.
Yeah. So let's shift to Alex. Alex, last time you were on the show was last year, where you came on to talk about Z-Prize. We actually did a two-parter. You were kind of like the co-host, leading us through the Z-Prize world. I think you've also been on another time. I did an episode on funding a long time ago. You were also the host of the ZK Study Club, which folks might be familiar with. That's over on the YouTube channel for the Zero Knowledge Podcast. But why don't you share with us kind of what you're up to today? Because last time you came on, you were the CEO of Aleo Systems. Now you have a new role. So share a little bit about that.
Yeah. So first off, it's been amazing to collaborate in many ways over the years, and it's a pleasure to be back today. Yeah. And as you mentioned in the introduction, I am now the executive director of the Aleo Network Foundation, which we just formed. It's new as of like a week ago. And we did this very intentionally, as Howard mentioned, because both Howard and I are really committed to, we want to walk the walk of decentralized network, not just talk the talk. I think there's a lot of excitement about blockchain and cryptocurrency and decentralized technology, but there's not a lot of teams or projects that are very far along that roadmap. And of course, we're also at the beginning, but we want to make sure that we set things up so we can actually achieve what I think makes Bitcoin, for example, really special. I mean, the thing that started this entire space, right? Bitcoin is like the guy that founded it literally just disappeared off the face of the earth, and it still works. This concept of a permissionless network kind of really deserves its own organization that's nonprofit, that's focused on the hard problem that Howard just mentioned, the hard problem, which I'm convinced will always be an unsolved problem, which is governance and social consensus, right? Because now that, we're imminently about to launch the network, it's not just Howard's anymore. It's not just mine anymore. It's going to be owned by all of the users, all the community members, all the validators, all the provers. And, the hope and the mission of the Aleo Network Foundation is to be the steward of that, right? And guide it in a direction that promotes use and usage and relevance, right? And that to me is, I think, another really important piece. So in addition to ensuring we hew to the principles that motivated the founders of the entire industry, we also try and do our best to guide things in a direction where this is about technology, but it's also about technology enabling real world applications. I mean, that's such a critically important part for me, right? Because I think, I got motivated to join the space because of what I saw as like fundamental problems, specifically with remittances and payments in third world countries. And, I think still to this day, crypto has not quite realized its potential. There's still a lot of hype, but there's still precious few applications, right? And of course, Aleo's pre-launch, so there's not really any real applications here either. But it is definitely my hope and my goal to take the Aleo Network Foundation and use its resources to promote real applications. And I think, obviously for many reasons, I'm bullish about privacy being a big part of like enabling real applications and decentralization, and also the programmability that Aleo provides. But yep, I'm very excited for this new journey, and it was awesome to work with Howard. Throughout my time, I think for context for everyone else on the show, I joined Aleo as the first employee, was the chief strategy officer, then I became the chief operating officer, then was the chief executive officer, and now I'm the executive director. So I've kind of been on like running all around. And the last thing I'll say is maybe just, I tweeted recently, like leadership is two parts. Knowing what to do and knowing what not to do, right? And a big part of what not to do is not to get in people's way. If I have any accomplishment that I'm proud of as being the CEO, it was enabling Howard to do what he was best at, which was be a technologist, and to get us to this point that we're at today. And so I'm incredibly thankful to have been part of the journey so far and excited for what's next.
I like that. Alex, also, you are the person in the community who consistently brings up the "we need applications" comment.
I know, I am a broken record.
In our chat on the stage of the ZK Summit. But I think it's a really important one. I feel like every time I see you say that, I'm sort of reminded to take my head a bit out of the sand. I feel like I get very excited about these technological tweaks and the cool implementations and these theoretical ideas. But I think we are still on the lookout for something real and something beyond maybe just private transfers, because I don't even know if that's really successfully done yet. But beyond that, like something where people use ZKPs every single day and they use it for something key. And yeah, I don't know if we've fully got that yet. Although there are some ideas.
I would argue we haven't, but yeah. Definitely there's some really exciting ideas. And that's like, look, it's great to be excited about this technology. I mean, we're all excited about it. It's super cool stuff, right? I'm sure all the listeners of your show are as excited as we are about the potential that it can provide. But it's just potential until it's realized in the form of an application. And that's its own journey. And I think it's important not to forget that, at least to me, as everyone now knows, because I bring it up all the time.
Yes.
To be honest, I feel like Alex's repetition around this concept is important because people in the current news cycle lose track of these motivations of why we're doing what we're doing here so quickly. Like you see, like on the one side, there is the kind of crypto price narrative, which tends to drive the short-term hype cycles. And to me, that can be frustrating because it's a big distraction a lot of the time when you're trying to build something that's long-term sustainable and meaningful. But then there's also the other side of things, which is the research side of things, where you're always trying to optimize for a new theoretical proof system. And sometimes that's specializing in the one domain or specializing into a general purpose domain, but it's touching on a different pain point than what the user cares about. There needs to be kind of this third leg to this whole story, which is really touching on the end product and the end user and the end goals of this technology. And I don't think that that's been adequately represented in this space. You know, I'll echo Alex on every one of the points he makes, again, and call us a broken record. I just feel like it's very much missing. Like there's no one out there that's really focused on, like everyone talks the talk, but very few are willing to put in the time and hours from my perspective and really walk it. Certainly in terms of the fundamental developments, in terms of the messaging, in terms of the actual outreach that's being done, a lot of it is driven by some of the two other verticals, not so much this one. And I think that it's something that continues to be missing in this space.
Well, I will just add maybe a little bit of a counter to this, which is I think in the past year with the hackathons that we've been doing with like my other hat, ZK Hack, we actually were seeing people pretty genuinely experimenting with the tools that exist on the application front, trying to build out, you know, all these different ways that we can start using this cool thing. And when I look at that, I don't think people aren't trying. I just think we're just at the point where people can start experimenting because the tools are just getting onto the market. I'm somewhat optimistic, I guess.
Yeah, no, for sure. And this is a long arc, right?
Yeah.
If you look at the history of the internet, or actually I just read a great article about the history of video games. I mean, it's like literally decades long, right?
Yeah.
So this is a long arc. It's early, and experiments are important. And so, you know, but it's, I think we're all committed to the long-term goal of having this tech be relevant.
Cool.
We all share that.
Yeah, I think there's like two aspects that people have finally started to reach group consensus around. One is after many years realizing that it's better to decentralize the verifier than to decentralize the prover. And that's something that I think has been a hard topic for people to recognize. And even in the roll-up arguments and the co-processor discussions, I think some people still haven't fully come around. But I think as a group, we've reached a form of consensus that, hey, like you should check the proofs on chain and you should do all the proving work off chain. I think that's one aspect that has helped to maturize a lot of discussion. Because early on, there was so much efforts to try to put the prover on chain. And I think that really hurt the progress of this kind of discussion. And then I'd say to the second point, which you've made a call out for, Anna, is that the stacks of these various platforms has improved enormously to the point that we're finally starting to be able to have developers write stuff that looks and feels a lot like JavaScript or Rust. They can write applications in a humane kind of way. It's not like computing polynomials by hand, although some proof systems still require that and stacks define around that for performance reasons. But nonetheless, we've reached a point where the average developer could come in, sans the performance optimizations, write a basic application and deploy it and see it happen. I think that's a big accomplishment to have made. But yeah, I think without those two things, we wouldn't be here today. And I really do think that we're still so early. This is like JavaScript V1 type of stuff that we're doing right now. It's just like limited POCs.
I want to ask one more thing on the application front before we move on, because I actually want to talk about the tech stack evolution of Aleo too. But what is the coolest thing that has been built or proposed to be built on Aleo so far? And I realize it's early, but I'm curious. What are you excited about? Is it ZPass?
I'll give my answer. Yeah. So my answer is ZPass, which is an implementation of a paper called ZK Creds, which is a form of decentralized identity. And I think there's a lot of discussion around ZK powered identity. But I think the cool thing about ZK Creds and ZPass in particular is that it requires both a decentralized network and privacy to work, and I guess a programmable blockchain. It requires this combination of programmability, privacy, and permissionlessness. Like without any one of those things, it's kind of redundant, right? So sometimes I'm critical of projects that only focus on the ZK part, because oftentimes there's like a database where identity information is stored that then a centralized party is just proving. There's use cases where a centralized prover makes sense. But I think in the case of identity, like if you're okay with someone vouching for you, like why do you need a zero knowledge proof for that, right? It's like just like OAuth, like the OAuth protocol works this way. Like I log into your site, Anna, and you just query Google and you're like, hey, does Alex have an account? Yes, he does. And then that's all you need. There doesn't need to be a zero knowledge proof there, right? It's just redundant. But ZPass, it enables you to have a form of self-sovereign identity where like the identity information based on a physically issued document, in the case of ZPass, a passport, like lets you upload that information on chain with an attached proof that it is a valid identity document using some of the same techniques that, like, for example, if people are familiar with TLS Notary, non-native signature verification, a proof of that. And then you have this digital version of your physical document that is tied to that physical document by this proof. And then you can make claims about what's on that document without revealing it, what's true and what's not. And you are the only one that can do that. There's not a requirement for anyone else, right? And that's where the blockchain comes in, is like, it's permissionless. So just like I can pull out my physical passport whenever I want, I can use this whenever I want. I don't need to be tied to some kind of API that's online, or maybe not. I don't need to worry about someone hacking a database, or not, And so I think, to me, the identity is the obvious and most near-term example of how I think applications, for ZK and permissionlessness and privacy, programmability are going to be kind of form around. And then from that, I think you get to payments, right?
Yeah.
Because I think, like, the first concept that comes up whenever you talk about private payments, people are like, North Korea, Iran, terrorists. And so the obvious answer to that is like, do some form of like on-chain KYC or on-chain checking. So there's some protocol that you do, but you don't want to reveal everything about yourself, because obviously no one like publishes their bank account information. So you have this like ZK version of this where you say, hey, I'm not a bad person, and now I can pay Anna or something, right? And so I think those are the two things that I see as immediate term applications that I'm really excited about.
That's interesting, because ZK and ID, we just recently did our predictions look forward episode. And I think all of us, these were the co-hosts, the sort of guest co-hosts of the ZK pod, we all had ZK ID on our list of like dream application for 2024. And there are some amazing experiments. I think ZPass being one of them. Actually, ZK Cred was even mentioned there. And I think it's going to be very cool to see them in action.
Totally.
To actually see them being used. And then we see what flavor of ZK ID works for which use case.
Totally. And the cool thing about this is it's novel. I guess the last thing I'll say is like, this is novel. You cannot replicate this with a centralized system. Like DeFi, okay, it's like novel in the sense that I guess it's permissionless, but it's not like an exchange is an exchange, right? This is a truly novel thing. Like ZK,
I think some DeFi people might disagree with you there, actually.
Well, sure, but take the mechanism of moving money. I guess if you care about it trustlessly, that's fine. But like take age verification online. There is not a protocol to cryptographically verify your age online for any online content. This is actually the whole point of the paper, ZK Creds. It's been an unsolved problem for the internet for decades. And ZK Creds and ZPass and these various identity solutions using ZK actually can solve that. And they like, the cool part about that is you can abstract the blockchain away. It's required for it to work, but you can abstract it away, and it solves a real problem that people outside of Web3 can appreciate. And that's the other reason I think it's really exciting.
Cool.
Identity is definitely one that I would strongly echo with Alex, is an important use case. I think it's also one of the closest to being practical and ready to use off the shelf. I think going one step further, I'm looking at ZK APIs or ZKML being the area that's most interesting to me from there. And the reasoning around that really is like a big part of what excites me about using ZK on the web is this ability to unlock data and access data that simply is there, but simply can't be used for, any sort of either business or protective or privacy reasons. And I think that this is an opportunity to actually take advantage of these types of systems and give it open access. Give it access to anyone for their purposes, to probe, to inspect, to use, to learn from. And this is where, even in Alex's example of identity to payments, like today to do payments, think about the statistical checks that are happening under the hood when you're using PayPal. Like just to click buy, the number of systems that have to parallel process your request to auth you through, it's numerous. And most of these systems need some form of authentication. And this is, I think, an opportunity to leverage existing credentials, turn them into verifiable credentials, and then take that information, that data, and actually give a statistically interesting proof about it, so that you can get from point A to point B with your assets. I think like this is an area that is also going to motivate a big part of hardware acceleration, because when you start reasoning about data at scale with ZK, you're suddenly going to need dedicated chips, dedicated machinery. And I think that is going to be a massive unlock for ZK proving times and ZK verification times. We haven't seen that emerge yet, but I think that we're just a year or two away from seeing the first examples of that really, really bring it on. And as much as I think, the ZK AVM idea, it's probably more of an intellectual exercise to me than a practical one. I do think that the motivation for that is well formed. It's coming from the right place. And I think that it's going to be applied to this general off-chain use case of just unlocking data for ZK.
I do think like the roll-up idea created the ideas that led to the coprocessor. I feel like there's been sort of a trajectory that you can follow in terms of thinking. And people sort of realized once you could do that, you could do more. Maybe you don't have to have it be always fully attached to the main chain. You can do more off chain. You just mentioned sort of this Web 2 to Web 3. And I know there's been some very cool experiments around that. We did an episode, just one of the last episodes of the year, which was ZK Login and ZK Email. These two projects that are very similar, but one's on Sui and one's on Ethereum, which is about taking Web 2 credentials, using ZKP to sort of bring them into the Web 3 context.
On the ZK, logins and authentication front, I think that ZK is probably going to be most useful for tying together different forms of authentication, because at the end of the day, like authentication, it's all about root of trust. It's all about provenance. That's why you need a chain. That's why you need this type of ZK tech. A lot of the times you can't do that type of native authentication in time in a browser with a server. And oftentimes you don't want to reveal all of that to the server. Recently, we've seen a lot of the industry shift towards passkeys. We're getting smarter, I think, as Web 2 emerges and hardware emerges for cryptographic elements and secure elements to actually reason about these types of algorithms. But I think over time we're going to start to realize, hey, there's so many of these types of like cryptographic pieces that I could actually combine them to give a stronger attestation. I think that's where ZK is probably going to really jump in and become like the actual center of mass, that root that everyone uses. I mean, even to this day, like I still think the privacy pass example from Cloudflare is a great example of a piece of ZK tech that is out there and used in the wild to basically, forego the trouble of redoing captchas over and over again. I think like that's a clear example of using the tech as a root of trust. Cloudflare is obviously the one that's issuing this. That could easily be decentralized so that you have kind of general provenance for anyone to verify. And I think that if more people start using tech like that, then you're going to start tying this stuff together, and it's going to end up creating a much more secure web.
Yeah, totally. And I was just going to echo the point that Howard made, which is that in combination, these things are more powerful. And I think actually some work that you've, kind of focused on in the past, Dan, is some attested sensor stuff, right? This idea of combining like a secure element or some kind of chip that signs a photo or whatever, and then you can use ZK and prove the photo was edited only in certain ways or something like that, right? So basically proving that things are authentic, I guess, from kind of a different definition of authentic. You're right. And then there's some really interesting work around combining other cryptographic primitives like MPC, multi-party computation, and ZK. So we talked about, hey, centralized, decentralized prover. Well, with MPC, you can kind of get the benefits of a centralized prover, but still have like privacy from multiple parties. This is probably something we're going to touch on as we talk about the tech of Aleo. And the other piece is, you mentioned like ZK rollups leads to these other ideas. And I actually think Aleo, I would posit, I'll let Howard, maybe give his own take, but I would posit Aleo and the way we've architected this, the way we've come to it, is the natural logical conclusion. And I think you see, whether or not people say it, the engineering direction that all of these projects have gone over the past couple of years is basically where we are, more or less. Is you have a separate system for data availability, off-chain proving, and a bespoke language stack. It's much more similar to what we are, probably, than many people would probably have first thought of when they started on the journey of doing the ZK VM.
Bold statement there, Alex. Your end game.
I'll add that I have a hot take that I've kept off Twitter for months now.
Ooh.
There's been all this discussion about we're going to decentralize the prover. We're going to decentralize the prover with these rollups, or these ZK UVMs, or these co-processor arguments. From my point of view, I don't think it'll ever be economically viable to decentralize the prover. Just think about, name your rollup of choice and the amount of demand that is going to induce the proving hardware of that one provider. Now think of spinning up the second hardware provider that's going to be doing proving on that network, and consider the need to split that pie up, like the actual rewards that are being issued, the fees that are being paid out to financially keep two of these companies in business is going to be so difficult, let alone add the third company or the fourth company. There's a reason why most people use Google. And it's, Google has this, majority market share dominance because they have enough mass and enough network effects as a company to actually financially sustain this operation at scale. If you had a second one come in and decentralize Google and do the same thing Google's doing for Google, I don't think that you'd have enough pie for it to go around for that. And I think that this is the point that you've touched on a little bit, Anna, and this is the one that Alex is touching on, is that people have started to recognize it's better to decentralize the verifier rather than the prover. And it's better to have an ecosystem of decentralized verifiers where you can have this kind of information and state available, but being proven off chain. And I think increasingly the story is going to become like ZK proving will be off chain. And I think that the story of ZK, the next chapter, is going to be a lot of development in that off chain universe because of the fact that the verifiers are going to be the cheapest and most commodity piece to really put on chain. It's also the thing that's stateless and small that you can leave on chain. But I think that a lot of that state needs to be proven off chain. And I think that the statements that people are going to be making are going to be so large that it won't make sense to host it the Ethereum way, meaning in a smart contract on chain, executing on chain.
Is this like the bear case for those prover marketplaces that have been proposed? Because there is this decentralized prover marketplace concept that's been floated around.
I mean, I give my take on that. I mean, look, I guess like we're making a prediction here. It could prove to be, there could be some application that's wildly profitable for it to be a prover, and maybe that would incentivize a prover marketplace. But I think what Howard's point is, which I strongly agree with, is like everyone usually hand waves the economics point, right? But the reality, even of a roll-up today, I mean, you could just look at fees of most of the ZK roll-ups, and you can just add up the fees in a week paid on the L2 and add up the fees that roll-up pays to the L1. In many cases, they're negative. In some cases, they're positive, but not by much. And so the actual economics of a roll-up, specifically a ZK roll-up, where remember, compared to an optimistic, I mean, the biggest cost for roll-ups is the on-chain data, right? So blobbing the data, and there's EIPs to address that, but are still not in, right? So the biggest cost is the data. But then ZK rollups particularly have the additional cost that optimistic rollups don't, which is the proof has to be verified. And that gas scan, however frequently you want to do that, that is a cost. And to really be apples to Ethereum or the L1 transactions, you have to consider like the time to finality, right? Because I can pay you on a ZK rollup, but I haven't really paid you until it's settled, right? And so the longer you make that, the cheaper it is for the prover, but it's less applicable depending on the use case. So I think it's not that the prover marketplaces, in my mind, won't be viable, but I think it is important to note that they'll only be viable if it economically makes sense. People take that for granted that they will, but I don't think we know that yet without the applications and without thinking through, because some applications would definitely favor a single party, depending on what you want to look at.
And in this case, like the provers would be like hardware running agents, right? Like, and you guys do a lot of work in this hardware direction.
I think people in crypto take for granted magic money being printed. And people don't recognize the cost of doing business is far more complicated than what meets the eye. Like we take for granted in Web3 that like tokens just magically come out and that we can just start to use them. And I think that has been a big part of what's bootstrapped existing examples of marketplaces, however limited they may be. Like I think Mina's an example of where proving marketplaces is emergent, but it's really based on the steady supply and steady rate of an emission curve. And without that emission curve, like these marketplaces today, like don't have enough subsidy to really exist. And to be honest, like even in Web 2, most of these marketplaces needed some form of subsidy, meaning venture money here, to really bootstrap themselves too. And so I don't think that this is not to really pin negativity around marketplaces. I just think that it's a far harder equation than people make it out to be, because Uber today is still trying to be profitable on this exact concept, on this exact business model 10 years later. And they're realizing how difficult it is to be just a marketplace. I think you need much more unit of economics in order to do that correctly. And a big part of that is also recognizing that you don't want to just be this thin horizontal stack. You want to be a vertically integrated layer if you really want to make this economically viable for yourself. And this is where I think, Google with, Waymo has taken an interesting stab at saying, hey, let's go autonomous, let's own the fleet, because then we can vertically integrate this market and possibly actually take on far more of the economics for ourselves so that this thing actually is viable. And I think this is the same thing that's probably going to happen with these proving marketplaces, that these proving marketplaces will likely be off-chain with a provider that's going to run hardware themselves. They're going to go and develop hardware that makes this economically viable for themselves. And I think that is going to be how you make this emergent kind of field actually practical for real business use cases. But without that, I think a lot of today, it's just subsidized by emission curves of these chains. And it's a great demonstration, but I don't think we're there yet.
I now want to shift gears a little bit and talk about the big changes under the hood of the Aleo system. I want to sort of, again, throw back to that episode that we did in August 2020. I was just thinking about it as we were talking. It's like I really got a chance to take a snapshot at the beginning of Aleo. And I know we're not at the end of Aleo, but we are at the point where the system is about to go live. So it's at least fully formed to the point where it can work. I'm super curious to hear what has changed. And I'll bring up a few of the things I want to cover. So I want to talk about the original idea of proof of necessary work or proof of useful work. I want to talk a little bit about the libraries. You sort of hinted at this, the libraries that you were working with back then, how those have evolved, languages, and all of that. But let's start with that system. So back when we talked, I think you had said the system would be based on Marlin. I would love to hear if you've made sort of adjustments to Marlin or Marlin as it existed. And then you had this proof of necessary work. Tell me what's happened there.
Yeah, so before I dive into it, also, I'm going to forget many facets. So just please help me by double clicking on certain things or probing questions.
Sure.
Because like there's a ton of changes here. So anyways,
Okay.
I'll jump into it now. Yeah, so on the Marlin front, we've continued to use this exact lineage of proof system. And for the techies in the room, we've added two major components to Marlin, hence a rebrand to what we're now calling Varuna as our proof system. Varuna itself is now a proof system that mimics Marlin. It is Marlin, but it adds the ability to support multiple proofs of the same circuit, so multiple instances of the same circuit, as well as multiple circuits at the same time. And so you can do in 2 dimensions, like multiple instances of the same circuit and multiple instances of different circuits all in one go. And this type of generality for what we call a batch proof allows us to actually craft and architect a much better compiler than existing language stacks that we've seen at least. There's the recursion kind of approach, and then there's this aggregation approach that we've taken. These are the 2 notable, avenues that I think have emerged. I think a lot of like the recent IOP-based work is starting to shift people in our direction, and they're starting to realize, hey, these primitives make a lot of sense because you basically get to prove more general statements for free. For example, I can prove, like, let's just say as a simple payment circuit, call it 1 second. Proving 2 of those payment circuits in a batch proof only takes 1.5 seconds. It doesn't take you 2 seconds. And if you prove 10 of those, it only takes you 1.8 seconds. And if you prove 100 of those, it only takes you 2.5 seconds. Like it grows super sublinearly. It's very, very flat. And it's that type of flatness that lets you scale in a way that recursion currently doesn't. So from a proof system standpoint, we've doubled down on the Marlin side. We've expanded it and we've rebranded it as Varuna.
You just mentioned the term aggregation. Is it related to the folding work, or are you thinking of aggregation at a different point in that stack? Is it more like finished proofs being batched, or is it like within the proofs themselves, some sort of like aggregation?
Yeah, so it's actually a good call out. I guess I should clarify that this is separate from the folding work. Both use primitives that come from similar lineages, but one of the big advantages about the design, which is also a trade-off from the folding scheme side, is that you do get full ZK in this design, whereas a lot of the folding schemes, like the folding schemes are very interesting for massive computations that have a lot of reusability in them, and this is where like ZKML is a classic example of that. Neural net architectures are just highly large and repetitive. I think that this is an example of expressivity of statements. And so what this allows you to do is to have more generality in terms of saying, I want to do a payment circuit. I want to do a proof around an identity verification. I want to do a hash function. I want to do a Merkle path check. I want to do XYZ things and batch them all into one go. And you can aggregate these types of statements all into one solution, into one proof. This takes it in a slightly different direction from the folding approach. I think that people are going to land on this as well longer term, but it's probably a few years away from really reaching that generality statement where people are just going to use this out of the box. So, I mean, we're still experimenting with the best architecture for it, and this kind of gets into the compiler side of changes. When we last came on, we just released Zexy, the library, which is now kind of forked into 2 universes. There's ArcWorks, which is the general open source research library.
Yeah.
And then there's Snark VM, which is the special purpose built library for Aleo. Both use the exact same architecture under the hood. In fact, if you check our trait types, they're virtually identical because we all came from this Zexy work and the original Zexy library. And Snark VM over time has actually changed a lot. We used to use the gadgets lib concept from libsnark in order to compile and compose our circuits. I made a really painful decision 2 years ago to scrap that and restart from scratch because we were working with our formal team to try to verify those circuits and the compiled out circuits, and it was an impossible task. The gadgets lib idea was right, and it's still right for a lot of research domain work, but we recognized at the time that we actually needed an additional layer of abstraction, a layer of abstraction that doesn't exist in research stacks, and that's the opcode layer, the opcode layer that traditional language and PL folks are familiar with. We realized that unless we had an opcode layer, it would be impossible for us to upgrade the system, meaning once you've deployed on chain, that was it. And if there's a vulnerability in one of the circuits, you wouldn't know which programs to turn off and which to leave on. That is a big challenge that I think we're only starting to realize the benefits or the merits of. So what we did 2 years ago was say, scrap the existing design. Let's rebuild every single operation as its own function and have every function be an opcode. Once we have every function be its own opcode, so now every opcode synthesizes one R1CS gadget,
Okay.
and it's clean on this level. Then from there, Leo was rebuilt such that it no longer reasons about R1CS or any circuit architecture or framework of its form, and it just reasons over opcodes. And so now Leo is a very thin language. It's a compiler down to a set of opcodes.
Okay.
And because of that, we now have two quote unquote instruction sets. We have the Aleo instruction set, and we have Leo, the language, which are the two layers with which developers can actually build an application on us. That did not exist 4 years ago.
Can you say that first one again? So it's Leo and
Aleo instructions.
Aleo instructions. Okay, I want to sort of map the lineage here a little bit because, yeah, back on that episode, you talked about libsnark. And at the time, I think it was the de facto library. This was what you were working from. There was a Zexy, I think almost just like test implementation, maybe at the time. I don't know. From libsnark, there is no transition to ArcWorks, is there? It's you throw it out in a way and you start again.
Yeah, we ported a handful of the foundational core algorithms over, but because it was a complete language change from C++ to Rust, we had to rewrite the thing from scratch, and that was Pratyush and I spending a lot of our nights in the lab doing this together. So
Okay.
yeah, it was quite a journey.
I did do an episode on ArcWorks a few years ago as well, so maybe we'll try to dig that up. But so ArcWorks and Snark VM sort of split, but coming from the same source. This is the porting certain things from libsnark, but discarding a lot of it. From Snark VM, so we'll go on the Aleo track here. You mentioned the Aleo instructions and then Leo. How do those things connect exactly?
Yeah, so we used to have in Snark VM a gadgets lib.
Okay.
And we threw out the gadgets folder altogether, and we implemented a new synthesizer folder. The synthesizer folder introduces the concept around opcodes, which are what we call Aleo instructions. So it's assembly-like. It's an assembly-like language. And the idea there is that every opcode maps to an R1CS circuit. So you have opcodes like add, sub, mul, div. An add circuit for a field is its own circuit. Mm-hmm. An add for an integer is its own circuit. And we basically write specific circuits for every single opcode. So we've mapped it from the language side down to R1CS rather than from the R1CS side up to the language, which was how we used to do it.
Yeah, and where does Leo go from there? So does Leo then talk to Aleo instruction set? Is it compiling down or is it directly interfacing with it?
Yeah, so when Leo first started, we actually mapped the high-level language straight down to R1CS. And actually, I think a lot of languages today from various teams actually still do this approach. Mm-hmm. And it wasn't until 2 years into that journey that we realized that there was a big upgradability problem with this. If any part of that compiler's circuits had a bug in it, and we learned it the hard way because our formal verification team did find bugs. It was impossible for us to trace and identify and resynthesize just the pieces of that circuit that were needed to be fixed. And so we said, let's change the architecture. Let's switch it to this opcode-based design. And Leo now is just a thin layer on top that just compiles from a high-level language down to opcodes.
Okay. So the opcode layer being Aleo instructions.
Aleo instructions, yeah.
Okay. Both of them is sort of Leo then, together.
Yeah. So the benefit is that Leo is no longer some special language that has to be the one in the ecosystem. It's a lot like in Ethereum. You have in the EVM, you have bytecode, right? Mm-hmm. And as long as you target that bytecode and the opcodes of the EVM itself, you can use any language you want. Solidity being the predominant one, but for those who are still around, from way back, I remember writing Serpent.
Was there something called Vim as well?
Viper. Viper is the other one.
Okay.
Yeah, Viper is the Pythonic version of Solidity. And so, people have realized that this kind of abstraction layer makes sense generally to target different domains, and we've done the same. Leo is one very clear example of a language that can target Aleo instructions, but at the same time, these opcodes in the AVM don't have to be limited by Leo. We can also expand it out to other forms. And actually, people in the community have. If you look at the ZKML use cases, people have written Python transpilers. And so you can compile Python code straight into Aleo instructions, into these opcodes. And it's much more useful because the ML folks don't know Rust. The ML folks don't use JavaScript. They primarily base their work in Python. And so they can easily write Python frameworks to do ZKML. And so they'll come up with some PyTorch model. They'll then synthesize the equivalent verifier for ZKML here in Python, and then we'll compile it down into opcodes that are then verified in Aleo instructions.
Can somebody use Rust somehow? Because I remember, actually at our last ZK hack, we did sort of a run through of ZK DSLs, I hope rightly, but we kind of classified Leo as a Rust-like language. So can Rust be used directly with Aleo instructions?
Yeah, so Rust can be used directly. We tend not to use it just because it can be complex to manage state yourself in Rust. Like Leo manages a lot of state for the user so that they don't have to reason about all the various abstraction layers that come with the system. It's the same as like you could write your Solidity contract, in JavaScript and piece it all together if you want, but you'd probably use Solidity at that point. It's the same idea here. So you can write it in Rust, but Leo continues to be kind of the preferred choice because it's stateful and it understands what it's reasoning over, and it can understand the inputs you're giving it and the outputs you're getting from it. So that's an abstraction that kind of emerges from there. I guess I'll hit pause, but there's one other feature in Leo that I think is really worth touching on as well.
Well, actually, I was just about to say, would you also say then you're building a lot of the tooling for like Leo then? And actually, who is building the tooling?
That's a great question.
Would it be coming from you guys, or is that a community project?
So Leo, at least in its current form, has been, and it will always be, an open source project. The company is continuing to focus around Leo and its efforts around proving using Leo. I think that there's going to be a very interesting collab with the foundation around how you design the UI UX journey for Leo programs in general, because we've, when we first introduced Leo, it was a pure off-chain computation language. You would write this code that would just execute off-chain, you'd send it on-chain and get verified. We then realized with a lot of applications, actually, you still want some of that peer-to-peer interactivity. And so we introduced on-chain executions with Leo. And so now you have on-chain, off-chain programming as a paradigm. And the challenge there was to actually design an interface for Leo that was intuitive for the developer to use. And we actually struggled with this for I'd say over a year and a half. Like we had kind of this function scope and this finalized scope. I think we even still do have a little bit of this function and finalized scope in the language. And it wasn't until about 6 months ago that we realized, actually, wait a second, this is just async await syntax. And we've started the transition in Aleo instructions towards async await. And Leo will also be getting the same update this year so that we can fully switch over from this old function finalized scope approach into this new async await concept. And the idea around this is really to say, I have this off-chain execution, which is really where the root of my computation is running. And then I'm going to send off this computation to finish on the network. And when it finishes on the network, it's going to send the results back. And I'm just awaiting locally for that result to come back so that I can continue my execution flow. So like, instead of thinking about transactions as these kind of discrete one-off computations, we're thinking more about like computations as a flow of execution that's happening across transactions, across blocks, across time. And it's a more general programming paradigm that maps into the traditional off-chain world. And that's something that I think is going to be very, very novel for Leo and certainly for ZK as a whole, that we're just starting to really hit on with these last 6 months. It wasn't until I think 3 or 4 months ago that we even realized what the right syntax was for this. And we started to realize for a lot of the functional programming folks that we can actually just take this async thing, call it a future, wrap the futures, we can nest futures, and all these calls to the chain are just futures that are just native to async await like concepts in JavaScript and Go and Rust, and it kind of completes this life cycle.
When you say futures in this context, though, is this like future actions in the language?
Exactly.
It's nothing related to like futures, like trading terms or anything.
Nah, yeah. Future
okay.
it's a language, it's a PL concept that has been around for web use cases. And so often when you're in a web app and you call out to some other either service on your or thread on your machine or to a service remotely, you'll use a future in order to await and parallel process something else on your machine in the meantime.
So that it doesn't block.
Yeah.
Exactly. So it doesn't block. Yeah, that's a great call out.
Cool.
And if I could just add on to this, like, so the implication, there's a couple of things. There's one thing I want to go back to. So first is that what Howard said, I think to state it another way, is that, you have a program, and that program, you can create transactions from the program. But really, because of what Howard is saying with the async await kind of paradigm, your program becomes a process in the same way that programs on your computer are processes when they're running, and those continuously can go, right? And I think it opens up a whole new world where people in, traditional smart contract blockchains are not really used to that, right? Where it's a single transaction affects a single state transaction, right? So now you can potentially have a long running process, which is cool, unlocks new things. The other thing is that going back to public and private state, right? This is something like Howard glossed over briefly, but like this was a huge effort for us to try and figure out how to do, both things. A disadvantage of Ethereum is that everything is public, right? But an advantage is that there's a lot of shared state and kind of, contracts can reference contracts, transactions can reference other contracts, and have it, a contract can call a contract, whatever. And this is like the classic question people always asked about ZK was like, how do you do Uniswap, right? And this was always the thing that, if you wanted to see people turn themselves in knots, that was what you would ask like a ZK researcher 10, 5, 4, maybe 3 years ago. But now this concept, maybe 2 years ago, maybe less, maybe
2021. Yeah, that was when they started to be like coming out. Yeah.
Right, exactly. But now you have a paradigm which mixes both public, like a public state and a VM that processes public state, with this off-chain processing, right, in the same paradigm. So now you can do Uniswap, but in a privacy-preserving way. In fact, Penumbra is this exact idea, right? And actually, Aleo, like the model that we have, is effectively enables Penumbra and other things, right? So we generalize the model of Penumbra, I would say, and that you can, in addition to just like focusing on exchange use cases, you can any kind of private state manipulation and any kind of public state manipulation you want to have governed by a single program, you can do that in this model. It's just the one thing I wanted to call out.
Interesting. And that is sort of dawning on me that like smart contracts, as we understand them, do not have that concept of futures. And so I'm just wondering, do you know of any smart contract platforms that are trying to incorporate something like this? Because it seems kind of powerful.
Yeah, so I think that people haven't really double-clicked on it on the smart contract level today.
Okay.
People do use this concept in JavaScript with Solidity programs. So like when you use web3.js, for example, you'll compose like multiple, state transitions for, let's say, some DeFi app this way. But they haven't gone to that layer of saying, what if I did my call it like my DeFi swap or something across multiple blocks in multiple transactions as kind of a step journey? That has not been formalized as a concept. And I think a big part of that is that the EVM is pretty ossified at this point, that it's really hard to introduce such a foundational change to the architecture.
Although could the co-processors do it? Because they get that off-chain element.
Correct.
Could they time it then to like happen?
Correct.
Yeah. Okay.
So this is where ZK really shines, right? Like you start to see this technology become a bridge so that you can take advantage of whatever stack you want under the hood to actually go and weave together multiple statements or arguments across time or across space. And I think that we are only just starting to touch on this with Leo, and certainly other people are. I think like the Risk Zero folks also are starting to see the opportunity of using this for this use case. And this works across recursions, also works across this kind of batch aggregation approach. It's something that I think is going to become more emergent once larger scale applications and multi-step journeys become a common concept with these types of Web3 apps. But today, because most of the use cases are DeFi based and they're, one-off like instant swaps or transactions, they don't have these crazy user journeys or these really complex or powerful statements that require multi-factor or multi-step computations to arise from them. And so this is where, we discovered this process in our goals and design of trying to build larger scale applications and needing to actually truncate basically these applications into multiple steps and realizing, hey, this is an opportunity to actually introduce a traditional language concept for web developers so that they can easily bootstrap in without having to learn new concepts for their own programming purposes.
That is so cool.
And if I could just say something super quickly. So we talked about Ethereum. It's traditional smart contract languages don't have this kind of feature. And I think this is actually something I wanted to go back to a comment I made earlier about how like there's convergence around kind of a set of ideas, right? And this is, I think, the concept of EVM compatibility, right? Huge talking point in many rollups, certainly, right? And I think what people have learned is that being compatible with the EVM gives you all the limitations of the existing EVM, right? And in fact, the way that people are building the ZK coprocessor direction is an exact evidence of this, is people are not building to be compatible with the EVM on all layers. They're building around it, right? And they're building a layer cake around it, right? Which is exactly what Howard is describing, right? So this is like, the EVM narrative, I think, was important for many of these folks to kind of bootstrap. But I think increasingly people are seeing it for its limitations, which, again, the EVM was groundbreaking in that it was the first example of a distributed, the world computer, right? Yeah. And now, of course, there's a million smart contract platforms. But so it was groundbreaking in that form. But it had all these drawbacks that now you can use ZK and the unique strengths of ZK to enable all kinds of new cool things.
So cool. Correct me if I'm wrong, but wasn't Aleo originally just proof of work fully? Or did it always have a proof of stake component? Okay. Tell me a little bit about what changed there.
Yeah, so when we first started, we started with a proof of work system, and we launched this on testnet 1 as well as testnet 2. And we realized during that journey a handful of things. We actually wrote a postmortem about some of the learnings from testnet 2, some of which included the realization that building a new novel L1 with a novel proof of work algorithm is, one, incredibly difficult, but also, two, a form of chain security risk. And we took a very conscientious decision to look back at what the right construct is for this. And so we ended up going towards more of a hybrid consensus, where now we have proof of stake alongside this work puzzle. The rationale around this, honestly, is to enable the security to be stake-based while also bootstrapping a new ecosystem with work. If you look at Bitcoin or Ethereum, the benefit of using the proof of work system, honestly, is to have stochastic distribution of tokens. It's one of the biggest challenges with stake, is that the only way for new users to acquire tokens is to buy tokens from existing holders. And that's one of the biggest limitations, in my opinion, for decentralization using the proof of stake approach. By having this work puzzle here, this puzzle enables people to actually go and, frankly, earn their own tokens just by the organic work process. And there is also the argument from people, well, work has a lot of, concerns around the environmental aspect, environmental responsibility and environmental sustainability. And this is why in our design, we've designed this puzzle to linearly decay over a decade so that its intended purpose, day one, which is to give a way for network participants to earn tokens without having to buy it, but by actually demonstrating and doing work, to over time have this mechanism fade out slowly, so that we can transition fully into proof of stake by 10 years from now.
Interesting. Has anyone done that? The hybrid? Is this sort of like a novel thing?
So there are example chains that do a form of hybrid. So I think, if I remember right, like Decred is an example of a chain that does something like this, where they have some proof of stake blocks and proof of work blocks. We've taken it a different direction and saying every block is proof of stake alongside this puzzle. Mm-hmm. And so, architecturally, I think we are very unique in our design. But people have touched on this point in the past because they've recognized the opportunity of the two different solutions at play here.
Okay, I want to shift a little bit and talk about privacy. Something that is obviously at the heart of the Aleo project. Howard, when we first spoke on this podcast, privacy was kind of like your main theme, topic, goal. At the start of Aleo, there was always this focus on privacy, and you're one of the teams, I know in our space, in the ZK space, there's been a lot of teams that maybe started with privacy and landed with scaling. In the case of Aleo, you've stuck to privacy. And I want to talk a little bit about your personal and maybe the company's perspective on privacy, if that's evolved a little bit, especially because now we have had a few ZK products out in the world, one in particular Tornado being held up as a dangerous form of privacy, at least by the US government. I wonder if that had any impact on the way you think about privacy. So yeah, tell me about the evolution maybe of the Aleo perspective on privacy.
Yeah, so when we first chatted about Aleo in 2020, the idea really was to make the entire system fully private. And we've learned through that journey that actually it's more about a spectrum of privacy, that you want to offer a developer platform that can offer everything from fully public to fully private based on your needs. And developers want that because some information you absolutely want to be public and others you want absolutely to be private. Like, I think the classic example is in governance that you want to keep your vote private, but you want to make the tally public, right? And so there's key information that's relevant to all parties to be able to publicly see. And we've really doubled down on the flexibility of that. So in early days of Aleo, every application's state was entirely private. Like there was no concept of public state and there was no concept of hosting public state on chain. And even with some of the new platforms like ZK Apps, I think on the new Mina platform, like it's still taking that model of saying you just have full privacy in this domain. And we realized that like this was a big challenge because a lot of applications need some form of public verification. And so we introduced this concept of public and private state into the programming language, into the stack, and into the chain so that we could host that there. I would say that from the Tornado side of things, I really think this is a moment for people to recognize that ZK can be used for good and it can be used for bad. And this is exactly the same point that past technologies have shown us too. Like no new technology is able to escape this argument. I mean, if you look at Napster versus Spotify, same end goal, very different approach to getting there, right? One was saying, let's sidestep, let's circumvent. The other said, let's go compliant, let's integrate. And I think that the story about what Aleo is trying to do is very much the Spotify story. It's saying, let's take this approach of using the technology for compliance and showing you how to integrate this into a stack that can be used in real world applications. I think like Tornado went the fast way. It was the first way. And it was that early wave that showed you how not to do it. But I think this is a real opportunity to actually give you much stronger attestations, much stronger credentials than existing Web2 stacks can offer you. And Alex's point around identity is a great one, that we can actually use this technology for good. And there's almost a need to offer this. I mean, I mentioned in the last podcast that, one of the big challenges with payments in Web3 today is the fact that you reveal all of your information, including your identity, every time you transact. And if you're going to use this for real world payments, I guarantee you this will not stand the test of banking privacy laws or any type of compliance on the web like GDPR, CCPA. There's no way to wipe that information. And so this is a classic example of, the UI UX journey is broken. If I'm just trying to buy an anniversary gift for my spouse, the fact that we're married means that I probably know my spouse's wallet address, right? And I can just go and look up, like, when did you remember our anniversary's coming up? How much did you spend on my anniversary gift? And where did you buy this gift from? And like, it just shows you like this, this UI UX is broken. Like if this is how we're using USDC in 5 years from now or in 10 years from now in the real world, I'm sorry, I can't use this technology. Like I think I would rather stick with traditional banking rails, for what it's worth. It's not the right user journey. And I think this is what privacy really opens the door to and unlocks for us. It's the ability for developers to offer privacy where it's needed and where it's necessary. And I think it's a fundamental part of the programming stack that's missing.
Yeah, exactly. And I think the USDC example is great because my favorite question to ask in every panel I'm ever on for a crypto conference is how many people here get paid in crypto? And inevitably there's a couple of people that like raise their hand and they get little contracts, but the vast majority of people that work in this industry get paid via the traditional banking system. Why is that the case? Because publicizing your salary is just socially, most places, not something people do, right? So even the people that are building this technology, by and large, don't use it because it is not private in this way, right? It's an example of like where privacy is just taken for granted. I think there's people out there that are like, oh, no one cares about privacy. Absolutely they do. If they didn't, they would just publicize their salaries everywhere, and they don't, right? But of course, there has to be a balance. And this is what I think the important thing that I just wanted to pull out of what Howard said is like, is technology. Technology itself can be used for bad or good, but I think the advantage of having a very rich or technology that can enable a lot of different things is you can find the right balance, right? Where you can both protect kids online by having like, a robust age verification framework, and you can prevent terrorists from like using this for money laundering, right? By using the same technology. ZK can basically use it for on-chain KYC to do payments, right? For each stage of the payment process, for a payments above or below a certain amount, to be defined however you want as the regulator or as the issuer, right? And so I think this opens up the door to, in fact, I would argue, more robust regulation in some ways, right? Because it gives not only individuals more privacy and therefore more protection, but it also gives like potentially regulators and lawmakers and, you know, existing institutions the ability to kind of define, hey, what do we think is legal or compliant? And then you can just write a program basically that says, prove that you're compliant. And so you could kind of achieve the best of both worlds, which is something unique about ZK.
Did you see that article from Vitalik about the return to the cypherpunk? How do you sort of match that with sort of the origin story of crypto? Also, your origin story, Howard. I just remember years ago you being very adamant privacy first. Do you feel like that shifts somehow here?
From my perspective, I'm doubling down on privacy. I think that this is a massively underutilized feature in crypto. We have not realized how bad it is because we've been living in a bubble where real-world applications don't exist. And when you don't have real-world applications, you don't have real-world implications. And without real-world implications, people don't realize that privacy is still a necessary function and it's a necessary feature. This is the exact point that I think Alex is making when it comes to the identity use case and the payments use case, that we need to have a form of privacy, a concept of privacy, if we actually want to use this tech with real people in the real world. And that is something that I continue to echo and I continue to feel very strongly about. And I think the example with Tornado Cash is honestly, it's a good example of what goes wrong when you don't respect the technology. This is an opportunity for us to take it the other direction and actually show people and policymakers especially that this is a very enabling technology, that I can start to do checks that previously could only be done in an audit and post factum, that I can now enable you to do things for compliance purposes before the action is taken, and that the action can be gatekept and can be guarded using these types of rails. And I think that that is a massive, massive opportunity that once regulators kind of come around and see this emergent property about this, I think that this will take off like wildfire.
Let's kind of continue on that regulation concept. So, you know, I just felt when Tornado happened, there was this kind of self-evaluation in the ZK space. A lot of teams had to make certain decisions. I think you've described regulators being able to almost use an Aleo-like system, but how do you as a network talk and think about your relationship to regulators? Have you had those kinds of conversations?
Yeah, I can take this because this is a big focus of the Aleo Network Foundation, is to be a steward of the network and to encourage its use in ways that are positive, right? And, you know, using it for bad, you know, breaking laws, for example, is not anything that we would ever encourage. In fact, we'll actively disincentivize with all the power that we have at our disposal. But I want to be clear here, going back to the very first thing we said, this is a decentralized network. There's not a server in the closet that's running it all, right? Like this is like Bitcoin, right? Like, so this is not just our network. It has to be the collective community that has to work together to ensure this, right? So we as a foundation are absolutely committed to doing it. And of course, you know, we in many ways have influence just by virtue of the fact that many of us worked on the protocol and, you know, and you know, we have great minds like Howard, you know, who's going to continue, even though he's the CEO of the company, he's continuing to serve on the technical advisory board of the foundation. So I think we have influence, but at the end of the day, you know, our relationship with the network is as stewards, not as owners. And that's just, to me, I think a really, really critical part. A, because I think, you know, I don't want anyone to misconstrue that like we can do anything unilaterally, right? Because that's not the case. And B, because I think, you know, that's actually what we want this to be. I think the promise of blockchain technology is you have these community ownership, right? It's kind of it's like the optimistic, the techno-optimist vision of like open source software, right? But instead, where everyone who owns it, you know, can basically realize in the value of it as it grows. So yeah, so I you know, we are constantly thinking of ways for engaging all communities, including regulators, policymakers, everybody, because I think exactly what Howard said is true, right? There's huge value in this for regulators. For example, I think, you know, if you were designing a CBDC, you obviously don't want to like reveal all the bank account information of every person in your country, right? You kind of do actually need to think about this, right? And then maybe you would issue it. I don't know, maybe this is overly optimistic, but maybe in 5 years, someone will issue a CBDC on Aleo. I think it could be a good use case. So yeah, so that's my view of it on the foundation. The last thing I'll say though is, people get scared, frankly, around this concept of privacy. They see people go to jail. And I think it just goes to show that this is serious technology. I don't think people should be afraid to build this tech, but also people should take it seriously because the implications to Howard's, I love the quote, like no applications, no implications. I mean, there is real applications of privacy tech and there's real implications, right? And I think we just have to take that seriously as a space. It's important tech that's worth spending time and worth building.
I have sort of a last question, which is, given that you guys are about to launch, Aleo is about to come online, security, you sort of talk about that responsibility aspect. I just remember when privacy systems were first proposed, one of the challenges of auditing these systems is, can you see what's happening inside these private zones? And I think we have the example of like the Zcash bug, from a few years ago where like there was basically a bug that would have allowed people to mint infinite tokens in a shielded environment, in a private environment, and there was almost no way to check. I feel like security in ZK is so fascinating because you obviously need to check and make sure that things are running correctly, but if you have these private environments, how do you see it? Now, it sounds like the Aleo system is more nuanced now, but I am curious what you're thinking on the security front, how you're addressing it.
I just want to start by saying we are all humans. And I think as humans, we are all doing our best and we are trying our best. And I want to say like we've done an immense amount of work on the security front. We've invested heavily on formal verification, not only internally and in-house, but also externally with partners to build out tooling to formally verify every circuit that's going to mainnet so that we can confirm that the R1CS is well formed there. In addition, we've also carried out extensive audits, 6, I believe, over the course of the past year and a half to cover every folder, every library in Snark VM and Snark OS to the best of our ability to certify that, hey, this has undergone multiple independent reviews and we found everything that we humanely could. And lastly, I'd say a big investment on the companies and the foundation's front is this bug bounty program to get the entire ecosystem involved in helping us triage and identify vulnerabilities on a software level, on a programming level, on a developer level. And we've found a long list of bugs. And we actually just published, I think it was 2 weeks ago, a blog post detailing our most recent round of audits from 3 firms, Trailbits, NCC, and also ZK Security. And, there were some very interesting findings in there. We fixed all of those. And I feel very good going into mainnet that we have a system that battle tested with the testnets to the best of our abilities. I think that going forward, there's going to be a major effort that needs to go in towards formally verifying Leo even further from where it's at today, especially if we add in these, concepts around async and await. It's going to take time, but also with every new arc that's proposed, we will also need to come up with a great audit process, a great bug bounty process around that. And I think there's much more we can do in terms of that. Now, as you've mentioned with like the Zcash security bug, with some of these cryptographic bugs, this is always a persistent concern. And I think one of the big facets that I'm proud about is the fact that we've open sourced the proof system and the prover from day one. We've never kept it closed source. We've always let it be open. We've also used it in various domains beyond just this network. We've used it in Zprise, for example. We've seen a ton of hardware developers, provers in the ecosystem build dedicated chips around this. And so this has been inspected by multiple teams, various teams, to vet for its correctness and its integrity. I would be very surprised if we missed something on the proof system level there because of that. Yeah.
What happens though, like say you did miss something, how do you find out about it and how does the system actually deal with it?
Well, I think this comes into multiple factors. As Alex pointed out, we are standing up a technical advisory board that's going to be going through all future changes, especially feature changes for the system. Where this is a classic concern that Ethereum core developers have as well with introducing new opcodes and new capabilities, is the fact that it opens the door to a larger attack surface vector, right? And so I think that coming up with a proper process to check that is going to be paramount. And then secondly, that if there are vulnerabilities that are discovered, we come up with a process and governance to transition everyone to new software. And this is something that Bitcoin and Ethereum have done multiple times, numerous times, is just, emergency upgrades so that validators are updated in a timely fashion. We've also contemplated on the programming level, this is where the opcodes really start to kick in, that, we introduced Aleo instructions as a layer of abstraction. So if we do find vulnerabilities in a specific circuit, even after verification, audits, and bug bounties, that we can still go flag those exact programs and detect them instantly, which programs have the vulnerability, and disable transactions for those programs as a steward of the network. That's something that I think is going to be a key piece of technology that no other language stack in ZK has built out to date. And I do think that we are probably at the cutting edge, if not the leading edge, of this type of paradigm for ensuring security and safety here. It's something that I can't understate enough. Or overstate? Is it overstate? Anyways.
Can't overstate enough.
It's something that I can't overstate enough.
I want to ask, though, when it comes to projects that are deployed on Aleo, because it has that smart contractness, and this kind of goes back to the tooling and are you conceiving of ways? Are you thinking about ways that people could almost do checks in private environments? And would you need to build those tools for the app developers?
Yeah, so we've really prioritized security by design. For example, there will be no need to deploy a safe math contract on Aleo. Every opcode is safe by default. We've introduced additional subcomponents of opcodes that can be quote unquote unsafe behavior. If you want overflows or underflows, those are the secondary choice. The default choices are always safe by design. And so we've tried to make it so that what developers intentionally write out the box is safe. And I'd say that the second piece, which is a really big composability narrative, is the fact that programs here are truly interoperable. In Ethereum, they're interoperable in the sense that I can redeploy the same contracts over and over again, and I can call out in that regards. But here, every program can actually truly reference existing programs that are on chain and reference their state and use it in a way that does not require you to redeploy the same logic over and over if you don't want to. And that's where the concept around a program registry really arises here. Program registries are critical for security because it means that the people who originally wrote the code are the ones who are best to service it. They're the ones to best upgrade it, and they're the best to address the issues when they arise. God forbid there's an issue in safe math, in Ethereum, and you deploy the thing and you deploy the wrong copy. This actually happened with the icon token. If people aren't aware, they had a copy of safe math where the arithmetic was off by one character, and it actually created a big software vulnerability for the token that forced them to do a migration. And so there are examples of this type of concern where we think that, just by creating a programming paradigm where you have, rails that you're safeguarded by and an environment that you're operating in using each other's safe code, that this is going to be a much better outcome for all of us.
Crazy. Do you have the entire governance kind of plan mapped out, or is that something still in the works? I just know this as a validator on different networks, like on Cosmos, what have you, or versus Polkadot or something like that. The way that the network is governed is very different.
Totally.
Is this something that's coming, or is this something that's already planned? Yeah.
There's already plans. So Howard mentioned the ARCs process. There's a repository. There's been people who've already submitted ARCs to change various things already to this point. Some of them have already been implemented and accepted and merged in. And, I think so that exists. And then I think the plan going forward is to extend and expand that. The one thing that, at least in the short term, we don't plan to integrate is an explicit on-chain governance where it's
voting.
We all vote with our tokens. In general, I find that to be very extraneous and not that helpful. And so I think our focus is really to make the best possible off-chain governance process. And by best possible, I mean inclusive of all voices, of all stakeholders, right? And having and transparent and fair in how things get discussed and how they get merged in. Even though we have something, it will 100% evolve and will continuously evolve over the course of this thing.
I think it's worth calling out that technology is made by people for people. And I think that this concept that code is law is not at odds with the concept around community governance. I think that these are both actually forms of code is law, just on two different levels. One is on the smart contract level, and the other is on the actual node software level. I think that at the end of the day, like if the technology isn't serving the purpose of the people who are collectively using it, then there is no point to using that piece of technology. And so like at the end of the day, like the DAO attack is a classic example of like what was best for the community and for the ecosystem's long-term growth was to do the fork. And that was the right decision there. Just as when Tornado Cash happened and the OFAC sanction occurred, that as controversial as it was the right decision as a form of social consensus to block usage of that application. And I think that this is reflective of the reality of why we build technology. It's to enable the majority of people to use it for the benefit of others. And if that is being abused, it needs to be fixed. It needs to be corrected. And I think that that is, by definition, the intention, for me at least, of what this code of law should be doing. And I think that that's, frankly, on a human level, what technology is meant to serve as well.
Wow. So that's a really good point maybe to wrap up this episode. But I just have one last question, which is what's next? I think we kind of know what's coming up soon. But yeah, what's Aleo looking forward?
Mainnet launch.
Very cool. Well, this episode comes out before the mainnet launch, but we'll be watching and very excited to see it all come to life. Howard, I've seen you through this journey for a very long time. Congrats on getting to this point.
Thank you. It's been a team effort and wouldn't be here without Alex. And I appreciate the kind words. I definitely look forward to the next podcast where we dive even further into this journey and see where we've gone.
Yeah.
But yeah, from my view and Alex's view, I think we both can conclude that this is like reaching base camp for us, and the journey ahead is just beginning.
Yeah. Thank you so much for having us. This has been fun.
Yeah. Thank you, Anna, for having me again. It's always been a pleasure.
Yeah. Thanks for being on. I want to say thank you to the podcast team, Henrik, Rachel, Jonas, and Tanya, and to our listeners. Thanks for listening.